we're going on with matrices, and one of the uses for matrices is to solve systems of equations. And I'm going to skip over the warm-up and just get straight to what we need. First thing we're going to do is, and these are the steps, but I'll show you how to do them in a minute, just write the coefficient matrix. Okay, key thing here is all equations should be in standard form. After that, we're going to find the determinant. Then we're going to find the inverse. But for the inverse, we take the determinant, and then we rearrange our values in the matrix to make it the inverse. And then we're going to multiply the inverse by the constant matrix. So the best way to do this is just to start with an example. First, make sure that both of these equations are in standard form and that all the columns line up. Like I've got x over x, y over y, and a constant over a constant. Make sure everything's in the same location. And our coefficient matrix is dealing with everything that's in front of a variable. So my coefficient matrix is 4, 2, -5, -1. That's my coefficient matrix. And then to get my determinant, I'm going to take AD minus BC, and that's all about the locations. Like this is A, B, C, and D. So I'm going to take AD, so that's 4 times -1, minus BC, which is -5 times 2. So I have -4, -5 times 2 is -10. So if I'm subtracting a -10, that's adding 10. And so my determinant is 6. I'm going to use that to find the inverse of my coefficient matrix. So the inverse of the coefficient matrix. Okay, and I'm using this from up here, all right? So if I put 1 over my determinant, so that means it's 1/6 times, and then I do D negative B. So basically A and D switch places. And B and C stayed in the same place, but they change signs. So I have -2 and +5. That's what that means. A and D change places, and B and C change signs. And when I multiply that, I'm going to get what's called my inverse matrix, the A to the -1. And I'm going to take 1/6 times each of these values. So I have -1/6, I have 5/6, I have -2/6, which simplifies to -1/3. And I have 4/6, which simplifies to 2/3. I just took 1/6 times each of those. Now I'm going to take this inverse matrix, -1/6, -1/3, 5/6, and 2/3, and I'm going to multiply it by my constant matrix. And those are my constants. Okay, so that's 7 and 5. And when I multiply these, remember when you multiply, you take an entire row times a column. So I'm going to take -1/6 times 7 is -7/6. 5/6 times 5 is 25/6. And then I'm going to do the next row. -1/3 times 7 is -7/3. And 2/3 times 5 is 10/3. Now I'm going to add these. So -7/6 plus 25/6 is 18/6. -7 and 25 is 18. -7 plus 10 is 3. And that simplifies to 18 divided by 6 is 3. 3 divided by 3 is 1. So 3 is what is my x value, and 1 is my y value. That's my, oops, sorry about that. That's my solution. And if I check it, okay, and the way you'd write this is 3, 1. And if I check it, I've got 4 times 3 minus 5 times 1 equals 7. Well, 4 times 3 is 12, and 12 minus 5 is 7, so that works. And then I've got 2 times 3 minus 1 equals 5. 2 times 3 is 6 minus 1 is 5, so it works. So that's your answer. Okay. Notice I was able to do, one of the things I skipped over, making sure that we can multiply this. This is a 2 by 2, and this is a 2 by 1, right? We do rows over columns. These middle two were the same, so I was able to multiply them. That rule still applies for all the multiplication. Okay, so we're going to try the next one. I've got x's over x, y over y, constant over constant. These are my coefficients. So my coefficient matrix is going to be 12, 4, 15, 5. And then I'm going to do my determinant. And the determinant is AD minus BC. So I've got 12 times 5 minus 15 times 4. 12 times 5 is 60. 15 times 4 is 60. And that's 0. Whenever your determinant is 0, that means that the inverse does not exist. And we call this a singular matrix. And we can't go any further with it. Okay, so let's go to number 3. And notice on this one, I've got y over x and x over y. I don't want that. I want to make sure that my x's are lined up and my y's are lined up. So I'm going to make this 3x and minus 3x, because the minus goes with the 3x, and then plus 5y. Just so that I've got everything lined up correctly. So now I'm going to do my coefficient matrix. Is going to be negative 3, 5, 3, and 2. My determinant is AD minus BC. So negative 3 times 2 minus 3 times 5. Which is negative 6 minus 15. That's a negative 21. That's my determinant. So now I'm going to look for my inverse of the coefficient matrix. And to get that, I take my 1 over my determinant, so 1 over negative 21, times, remember, A and D trade places, so this is 2 and this is negative 3. B and C stay the same number, but opposite signs. Okay, so that's going to give me my inverse matrix. I've got negative 2 over 21. A negative over negative is positive, so 5 over 21. Negative 3 over negative 21, which is going to be a positive 1/7. And negative 3 over negative 21, which is also a positive 1/7. Because negative 3 over negative 21, 2 negatives make a positive, and 3 goes into 3 once, 3 goes into 21 7 times. So that's my inverse matrix. I'm going to take that and multiply it by my constant matrix, which is negative 5 and 19. And this is 2 by 2. This is 2 by 1. Since these are the same, that means I can multiply them. So remember, when you multiply, you take the row times the column. Let me just see something just real quick. So if I take the row times the column, negative 21 times negative 5 is going to be negative 2 over 21 times negative 5 is a positive 10 over 21. 5 over 21 times 19 is going to be, 5 times 19 is 95 over 21. Yes, that they are really this weird. Okay, then I'm going to take 1/7. 1/7 times negative 5 is negative 5/7. And 1/7 times 19 is 19/7. I'm going to add those. 10 and 95 is 105 over 21. Negative 5 and 19 is 14 over 7. And those can simplify. 21 goes into 105 5 times. So this is 5. 14 over 7 is 2. So those are your answers. And then what you do is you plug it in to check it. So if I'm checking this, I've got, I'm going to go with the original equation. 5 times my y, which is 2, minus 3 times my x, which is 5, equals negative 5. This is my check. Well, 10 minus 15 is negative 5, so it works there. And then I've got 3 times my x, which is 5, plus 2 times my y, which is 2, equals 19. 15 and 4 is 19, so that works. So my answer is 5, 2. Okay, and I'm going to stop there and do the technology on a separate video. Go forth.